Hello and welcome to this last video of this section of the course. Here we'll be simulating how a quadratic equation can help us to simulate projection of a... Hello and welcome to this last video. Here we're relating how to use a quadratic equation to simulate a particle moving under gravity. So moving under gravity that is thrown from somewhere is called a projectile. Projectile motions are good examples of situations where a quadratic equation can be used, because a quadratic equation has a graph that's symmetrical, and most projectiles have a symmetric shape if we ignore the wind resistance or the fact that wind can have an effect there. Alright, so we have been told that a spear is thrown from a tower with a height of h in meters, and the spear is above the ground after t seconds. The height of the spear is modeled at time t with this quadratic equation. Notice the coefficient of t square is a negative value, so it does have a dome shape. Look at the graph of this curve here. Now, in part A, we've been told to interpret what is the meaning of 12.25. This 12.25 is the y-intercept of the graph, and that happens where? When does that happen? When the value of t is 0, we will have only this value as the height. So at time 0, the sphere is thrown from there. The spear is thrown from top of the tower. Therefore, the height of the tower at the point of throwing the spear is 12.25. So if you want to model the situation, it looks something like so. The top of the tower is here, and the sphere travels in dome shape, or here, where here is the ground. So at some certain point in time, it will hit the ground. So in part B, we've been told we've been asked how many seconds does it take for the spear to hit the ground. So that's the value of h is 0. The ground is where the height of the sphere will be 0. So you set this equation equal to 0 and you try to solve for t. Now, it might not be factorizable by hand, but you can use your graphic calculator or any other calculator to help you find the answer to this problem, or use the quadratic formula. So if you use the quadratic formula, we'll get two answers. One of them is negative. Because the value of time has to be positive, we're going to discard the negative value and take the positive value to be our answer. After 3.68 seconds, the value of sphere will hit the sphere will have a height of 0. Alright, so having answered part B, we're reading part C now. Part C of the questions telling us to write the equation in a completed square form, where a, b, and c are constants to be found. So let's do that. We're going to start by factorizing a negative 4.9, the highest power of t. The coefficient, we can rearrange the terms, and once we factorize negative 4.9, that means we have to divide 14.7 divided by negative 4.9, and that will give us this value of 3, or rather negative 3, because we divided by negative number. So I'm just going to write what happened here is that we factorized negative 4.9 out of only the first two terms. We left this last term as it is. So 4. divided by negative 4.9 gave us this negative 3 here. Now we need to divide this negative 3 by 2 because we're going to put the square outside of the bracket. So we'll get this situation. 3 divided by 2 is going to be, rather negative 3 divided by 2 is minus 1.5, and 1.5 square is 2.25, and we always subtract this value square. Then we can multiply this negative 4.9 by this negative 2.25 so that we can combine these last two terms with each other. When you multiply these two values with each other, you end up with 11.025. Now you can combine 11.025 and 12.25 and you get 23.27. Now you have finished completing the square. At this stage, we found the value of A, B, and C. Notice that this is the value for B, or rather B is just 4.9. Our value for C, 1.5, 1.5, and value for A is 23.275. Reading last part of the question, it says, using your answer to part C, or otherwise, find the maximum height of the sphere and when it reaches this height. Well, of course we can do that, because we know the greatest height is this point, uh, 23.275, and it will occur when t is equals to 1.5 seconds. After all, that's the turning point of the graph, because the graph, we said, looks like something like so, where the top of tower is here, and we figured out, and the, the line of symmetry is at t equals to 1.5. Alright, so the coordinates of 1.5 and 23.75 to 275 is there. Alright, happy practicing. I'll see you in the next video.